Oh, wow. Is that a mockingbird? Is that a mockingbird? Oh, wow. Is that a mockingbird? Guys, welcome back. We're going to learn about some arrays and Solidity. Okay. So let's cover it. Arrays are great. They're a bit of like data storage. So let's read what we have here. And let's see. So working with arrays in Solidity can be tricky. We'll need to understand the data location or where the array is stored. Fun. Okay. So we'll also need to understand the memory allocation, whether it's a fixed size or can be a dynamically resized array. And this is really important, especially dealing with smart contracts, because if we have what would be called a dynamically resizable array, you could technically attack a contract through that. So this is important to deeply understand, because if you could keep resizing the array, if I'm a hacker, I'm a bad actor, and I want to destroy a contract or at least slow down a network or something, I could just keep push things into that array. I could just keep expanding that array until it's ridiculously expensive to run that function or something. So fixed size arrays is kind of important in Solidity. That's a super important and proper thing to kind of understand. So we're going to cover more of that today. So we'll bring these concepts to light in this coding tutorial. Don't worry. I'm not worried. Okay, so here we just have our contract on the right. Let's zoom in a bit for y'all. So fixed size arrays. The sized arrays have a set amount of values at compile time. So we can predetermine, this uint3, it means we're holding 3 numbers in an array. So we've already predetermined the size of the array, or this address 1 means it holds 1 address. Okay, so let me actually zoom out just because the resize is looking a little bit funky. Didn't realize I can't resize this. But okay, so my understanding, we could do stuff like uint4. It says X, we could have 4 numbers. So I could have 1, 2, 3, 4. There's 4 numbers there. I could also have less than 4 numbers if I wanted. But what I cannot do is have more than 4. That would not work. So that's what this little bracket here with the number 4 is indicating, is we could have 4 numbers there. So with Boolean right here, it says 4 Booleans. So these arrays have their size determined at compile time. They cannot grow or shrink in size. The contract will always allocate that space for them. That's awesome. Okay, so if you store less elements in the array than the fixed size, the rest of the elements will be the default value for the data type, i.e. false for bool so false for bool and 0 for uint. If you store more elements in the array than the fixed size, you'll get a compile time error. Okay, so the above array declarations will work in for state variables inside of a function. However, we will need to specify the data location of an array. So we have to prepend it with this memory or storage. Okay, so let's read a little bit about that. So the data location for this array is memory. Memory is temporary. It will only last as long as the transaction. Okay, so it's just like temporary, quick little state. Like here's the quick memory. The other data locations are call data for referring to message call arguments and storage for persistence, a little bit longer than memory. Okay, so let's take a closer look at data locations real quick. So, but we have call data, storage, and memory. So let's just vaguely glance over these. I think these are important concepts to understand. So call data, when we broadcast a transaction from an EOA to the EVM, the Ethereum virtual machine, from a wallet to the machine, we send data, which includes an identifier for the function we're targeting and the arguments we're sending. Okay, so if we're referring to this message directly and we don't want to change it, we can use the call data location. This makes the argument as read-only, and we cannot modify call data. Okay, so let's think about that one more time. So if we are referring to this message as call data directly and we don't want to change it, we use the call data location, making it read-only. Okay, important to remember. Call data, read-only. Memory is a temporary location provided for us to keep our local variables in. These variables will only exist in that scope for the length of the transaction. Okay, so memory is like state for a function, if understanding that correctly. When we're working with arrays, that should only exist for the length of the transaction, and we'd like to modify them. We label them with memory keyword, or the memory keyword. We can read and write to this data location relatively cheaply when compared to storage. If we use this keyword in the parameter list, it will make a copy of the call data array, which can be modified. So we can read and write to memory, relatively cheap to storage. If we use this keyword in the parameter, it will make a copy of the call data array, which we can then manipulate that one. Okay. Storage. Storage is the data that actually gets stored on the blockchain. This is where the state variables will be stored. Interesting. So memory is this kind of temporary thing that we can interface with if we need to transmute and handle data. Storage is going to be a little bit more of the database-esque thing where it's going to be more of some piece of data that gets onto the blockchain. Okay, so this is where state variables are stored for all the nodes operators in the network who store the state on the blockchain. This increases the amount of data they need to store. For this reason, storage operations are very expensive. So we kind of want to avoid storage operations unless we need them. Not that we want to avoid them, that's maybe not the right way, but we want to understand, okay, storage is expensive, memory is a little bit less expensive, and call data is probably going to be the cheapest of the three. So we need to know when to use which. So assigning an array will copy it in some cases and store a reference in other cases. Let's consider this example. So it looks like we have a memory right here, memory array. Will modifying memory array modify the actual numbers? Let's see. Looks like it doesn't. So he's still console logging numbers at the 0th position, and we're still returning 1. Okay, so this will not modify the numbers. The value from numbers are copied into the memory array at this assignment, and they are otherwise unrelated. Interesting. Okay, so memory array is it's a copy of the numbers array when we do this. That kind of makes sense though. So when we think of JavaScript or other object-oriented languages, this seems congruent with how that would behave. Is, hey, we have an array as the top thing, we make another array, like a copy of this first array, and then we play with the copy. If we print the first array, it's still going to print the first array. That seems appropriate. Okay, so in fact, the compiler will warn you that this can be labeled as a view since the function is not modifying any state. So this is, again, our state. This is kind of like our function state, the storage, if you will. But this does change. Okay, so this does actually change the state here. Will modifying the storage array modify the numbers? Yes, it does. So that is good to know. So view, or it becomes a viewable function when it's a memory thing. And then if it's a storage variable, we can actually modify that and it's no longer viewable. So let's see, this will modify the external. This will modify the numbers. In this case, the storage array reference contains a reference to numbers due to its storage location. Interesting. So I almost want to read this, but we should probably get back onto the thing. We'll just run over this real quick. But in short, it looks like the storage will put a pointer to both things. So if we have a storage, so we have an array. Here's our first array. We make a storage array of that, like a copy storage. Really, it's pointing to the same place in memory. So if we change the argument of this second one, we're pointing at the same place. We're pointing at the same location of memory. So that would change the first argument because they're both reference to each other. Okay, so that's deeply important to understand. All right, let's get back onto the main task here. So retrieve elements. We could also retrieve elements from our array using equal indexes. We should roughly know that if we've gone through JavaScript and other object-oriented programming languages. Okay, so we can loop through things in Solidity just like this. Our goal is to find the sum. So create a pure external function called sum, which takes a, let's see, so we need to have a uint of, it says 5 unassigned integers. So say 1, 2, 3, 4, 5, or 6, that's fine. And let's see, so uint, we could say array, maybe I'll go ahead and make it a public thing. We'll say function sum like this, and this needs to be an external pure. Does it matter the order? Actually, a pure external function. Okay, cool. So find the sum of all the unassigned integers within this array, and then return it as a uint. So what I want to do is obviously loop through for let I equals 0, I less than array length. We could actually just go ahead and hard code 5 because we already know the array length. And what we could do if we wanted is store a variable called max or even array length if we wanted to clean up the code like this. Could do something like this so that way we could always change things on the fly if we wanted, but we'll just keep it easy. Okay, so let's see. So we'll have this is Solidity. Okay, sweet. I didn't realize if we were in JavaScript or Solidity for a second. Had to double check the dot sol. Okay, so I want to number equals, what would this be? Array I would be our number. And what do we want to do? We want to find the sum of the unassigned integers and return it all as a uint. So I probably want to store a variable called a total value as well, potentially. And let's see. And we actually want to say total value is plus equals to the number. So that's going to keep adding everything to the total value. And then I believe we could just return the total value. So let's see how much of this works and how much of it doesn't. Okay, so return, boom. Oh, maybe that's wrong scope. Forgot for let I. Okay, so for let I. We got to do uint I. Nice. Return total value. So turns do uint, forgot. I forgot. Okay, so this is where some of the stuff is breaking. So for uint here, why? But this expression potentially reads uint number array equals I. Why is that not working? I figured that would probably work, right? What about that? As a pure, but this expression potentially reads from stores. Is that what it's saying? Is that what it's trying to say? I can't side scroll. Looks like this array I is not working. So uint total value. Oh, you know what? So this is create a pure external function sum, which takes a fixed size array of 5 unsigned integers. So this is modifying the state. So hold on. Maybe I read the directions wrong. Let's look at this one more time. So create a pure external function sum, which takes a fixed size array of 5 integers. Got it. You know what? This is where I went wrong, folks. I think I need to go uint 5 array, something like this. Let's try that. Okay, so uint array. Oh, we need to do memory or call data. That was a huge part of this. So what should we do? Should it be memory? I think it should be memory at first, right? No. Oh, it looks to be that fixed that. Okay, so then the total value is going to be the one that we need to handle now. Now, what is going on here? So function declared as a pure, but this expression reads from I can't read it over there. So we're manipulating the state. So we can't do that. So what does it need to do? Find the sum of the integers unassigned here. Let's see. So we have a total value deal. You know what? I wonder if we could just do this all within this guy right here, like this, right? Uint memory total value. Would that work? No. Okay, so I'm trying to understand why this isn't working. Data location can only be specified for array, struct, or mapping types. Let's take a look-see at their answer. I feel like we're really, really close, or I feel like I'm really close. Let's see. So function uint 5 call data and returns the total. Got it. So you don't have to declare the total value. You could just, got it. Okay, that's cool. And they actually did this. We could say returns uint total. Boom. Where's total value? It's not here anymore. Oh, right here. Boom. Got it. Does it work? Nice. We got it working, guys. We got it working. Okay, so that's an important deal. And they actually did call data here instead of memory. So that would be cheaper. That would be a lot cheaper. Very interesting. Very, very, very interesting. Okay, let's move on. So dynamically sized arrays. We can also create arrays in Solidity where the size is unknown at compile time. These are called dynamically sized arrays. So these are typical to the arrays you use in JavaScript. The difference is with JavaScript or storing something on a database, it's going to be a lot cheaper than the blockchain. So typically, now obviously there's some layer 2 solutions coming out to try to fix these things, but let's see. So we have an example here of to log the friends, which takes an address of call data of friends or an array of the call data friends. That's an external viewable function. We're looping through. And then we're console logging the friends.i. So here we are able to log each address that is sent to the log friends function. We use the length member available on the size of the array to determine the number of elements inside of the array to determine the fixed size. So our goal now, create a function called sum, which takes a dynamic array of unassigned integers. So we'll probably do the same thing here, right? So uint array, let's try the call data. And we'll do that underscore array one more time. It needs to be a pure external function. So do we do external first or pure first? It's the question. And what it needs to do is return. Is this not very similar to what we did? We're just doing it with with a dynamic variable is what I see. So for uint I equals 0, we want to take underscore array dot length less than, I less than this array dot length, I plus plus. And let's go ahead and do this. So we could say total plus equals again to add up all the array numbers of I. Boom. All right. I think that's it. Oh, and we made it to return total. That'll work, actually. Got it. Okay. Easy peasy. We did first take Drake that, technically. Almost. I'll knock off a little point for continuing working. But okay, so we just have a normal for loop here is what it looks like. Just with a little bit of Solidity syntax on it of, okay, we need to return this, we need to do our viewable function stuffs and our pure and external deal, and just prepend this with our call data. So just kind of defining a little bit of where the memory is and how this thing is viewable and what we're returning is what I'm seeing the difference is, right? Between maybe a JavaScript or a TypeScript and Solidity. It's more TypeScripty. It's just memory's thought about as the types instead of just like typing things. Okay, so I'm going to move my face way over here. With arrays in storage, you could use the push member function to add a new element at the end. Got it. So just like typical good old array, we could push elements into the array. So the length, of course, adjusts as expected. And let's see. So we could create a public dynamic size array. So we'll say uint array public and boom, even numbers. And we want to create a function called filter even. I'm going to move my face back over here, which takes a dynamic size array of unassigned integers. So we're going to do that same deal we've been doing. So we have a uint unassigned call data array. I imagine this will be an external. And let's see. So it takes one more time. So it takes a dynamic size array of unsigned integers as its only argument, find all the even numbers and push them into the even numbers array. Easy peasy, guys. So let's do that. So we say for uint I equals 0, semicolon, and then we want to do our underscore array dot length, of course, I plus plus. And what we want to do is if the array of I, so that's going to be an individual number, divided by 2 or modulus 2 equals 0, we want to push it into our even numbers array. So we can do this. And do we need to return this as well or what? So find all the even numbers. Oh, and then we need to do a stored array. What's that all about? What is that all about? So create an external function. One more time. So find all of the even numbers in this array and push them into an even numbers storage array. That's messing me up a bit. That is messing me up a bit. So create a public. We need to make this say storage up here is the question or no? Okay. Well, let's see. Returns even numbers and we'll try that. How about that? Okay. We don't need to return here. So external returns storage. Interesting. All right, let's try that. Sweet. Okay, let's double check real quick because I want to understand the storage bit a little bit more granularly. So let's take a peek, see at theirs. No, it looks like they public uint call data. So why did they say storage? Was that just to throw us off? A bit? Let's double check real quick. So filter them into a even number storage. Maybe they meant it kind of in a different context, like just your basket of even numbers. Okay, so memory arrays. Unlike storage arrays, memory arrays do not have a push member function, so we can't push them because we can't modify the data. So memory arrays can have a dynamic size if the size is provided during initialization. So for example, here we have a contract. We have a uint x equals 5, a function create array view external address memory addresses. So he's building a array of 5 addresses, it looks like. Boom. So the size is dynamically provided up here. So we can change it, but it's already still predetermined when the contract's deployed. It's not changing as the contract's being added to values. It's here's still the fixed amount that you can have. Now you could update the X, but it's a fixed amount still. So that's kind of what we did earlier where we said, hey, we could have like an array length variable. Maybe that was like, I think either on the first one or maybe the second exercise. Notice the use of the new operator here during initialization. So we need new right here. Good to point out. So after initialization, memory cannot be resized Memory arrays cannot be resized. This means even in the example above, once the addresses array is initialized at 5, it will stay like that for the entirety of the transaction. Now, my question is, could we have a function that changes the X size? I bet we could, which would be kind of interesting. But how do you change that? We'll have to mess with that in Remix sometime. But okay, so your goal, filter even numbers, create a pure function. So we'll say that filters even. So pure external. And it looks like it takes in a dynamic size. What does it say? Dynamic size of unassigned integers. So we'll try that one more time. But does this need to be call data? What do we need here? Takes in a dynamic size of unsigned integers as its only argument. Find all the even numbers. Add them to a new array in memory. This array should contain only the even numbers. So to be transparent, I'm not sure the difference from the last one to this one. So when we did this, we had call data. So is that it? We're just changing that to memory? Huh. Well, let's start getting to work. Let's see. So for uint I equals 0, do our same array.length, and we'll say I plus plus if underscore array of I modulus 2 to find the even numbers. If that is such, we want to obviously return an array of even numbers. So the array we want, I suppose we can make it whatever we want, but let's real quick. So find all of the even numbers and add them into a new array in memory. So in memory, that to me sounds like they want us to build something inside the function, like just something that's just in memory for the function. So let's try that. So uint, we'll say array here just to differentiate it. It doesn't have the underscore and it'll just be empty. So it needs to be dynamic, right? Is that for us? I know they said after this, we talked about having a hard-coded 5-sized array, but here, what do they want? Do they want us to have more? Takes a dynamic sized array, find all of the even numbers and push them in an array. So this can all, okay, so I think this will work. So push array of I, and then we do need to return that array. Oh, not the memory, the array. And I just need to up here put a uint like this, believe, memory push. Okay, so we can't do, it's not memory, it's array. Returns uint array. Do we need that? No. Memory array. Alrighty, guys. I'm a bit next here. Okay, so let's take a peek-see. Let's take a peek-see at some stuff. Let's look at this. So we have a contract with over 5 filtered index stuff. Okay, fun. Let's see here. So we have our contract. Oh, it is going to be a bunch of that stuff. Okay, so this is a whole different thing. So filter even. Create an array in memory. Which is the number. Interesting. Fill the array and return it here. So we can filled. How do they do that? So first it looks like finding which numbers are even and using that as the length. So to find this in number, right? This is what they're first deciding, right? And then making the array length the value of n. So n is getting incremented based on the number of even numbers here. And then they're using that n to determine the length of the array. That's genius. It's brilliant. Now, what is this part doing? So fill the array. So uint filled. Why do they have the filled variable? What does that do? I don't see them returning it at all. Oh, right here. Okay, so what is this? So filtered. So filled gets incremented. Is that just to be the same length of n, basically? Why would they have the filled bit there? Guys, we're gonna break this down. We're gonna get it. So let's take a look, see at the details and see what they have to say about a few of these things. So this is quite a bit longer, but we do it without a push thing. Okay. So let's try to not look at it now that we vaguely looked at it, but let's do a few things here. So we want uint 5, right? Or uint n, and then we want to say function filtered. Oh, you know what? Are they using this as? Okay, let's take a peek-see. So we have call data numbers, uint n, right? So for uint I, so similar deal. We're still finding the even numbers, but this is just to get the array length. So that's all we're using this n for. So it's just pre-looping through everything just so we can figure out how big do we need this array to be. So it's going to go through the array one time, boom, 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 and tell us, okay, there's seven elements that are even, or there's 3 elements that are even. It'll let us know. It'll increment the in right here, right? You can even say number of even numbers would be an appropriate name even, right? Okay, so that's what I understand here, that we need to determine the uint array length, array of even numbers equals, what was it? New something, new uint this, right? Something this or this, right? So I believe that is going to build us the array that we actually need, this array right here. And from this point forward, this is a tricky one, right? So yeah, that looks like, oh, we need to do a memory deal. Okay, so that'll work there. And this part I don't understand. So keep an index for the positions we have filled. So it just maybe bumps it along. That kind of makes sense. Okay, so we'll say uint filled index. We'll just go ahead and kind of copy this one down and see what we have. Okay, so for uint I, where's this numbers coming from? Is it still the array length? Looks like it. We still want to increment through, and if numbers, or if the array I, right, this is where we're still checking for evens. And this little bit I don't fully understand. So filled index, don't fully understand. So we can have the array of even numbers for us. This would be this bit for our deal. Filled index equals the array of I. Okay. And then we of course need to increment the filled index. Now I'm not sure what this is really doing, to be honest. So let's see if this is working real quick. Array of even numbers. I think what it's doing is just filling up the array. Return array of even numbers. Do I need to, right here? So I need that bit, returns memory, or excuse me, uint array of memory. That should work, but okay. So this little bit right here, let's break it down. So this other part I understand. So we're counting the number of even numbers in the array, just to again kind of say, okay, how big does this array need to be? And then we're using that number of even arrays just to kind of dynamically but statically prepend the level of memory needed here. And then this bit, it looks like we're assigning inside of this new array. Okay, that does make sense. Okay, so in this new array, we're not pushing, but this is our push function. So we're saying, hey, in the array of even numbers, first at the 0th index, can you put the first even in there? Go ahead and pop the first even in there. That's what it's doing. And then it's upping it to the second even, and then the third, and then the fourth, and then the fifth, or the fourth, I guess technically, if there's 5 items, so 0, 1, 2, 3, 4, and then obviously incrementing the filled index through each iteration, so it can do that. So that makes sense. And obviously, we're returning the array, or I shouldn't say obviously, not so obviously, we're returning the array of even numbers. But this is acting as our push function, and we're indexing through to get the next item to push. Okay, that makes sense now. So step 1, loop through to just find out how many even numbers there are. Step 2 is make that array in memory. Step 3 is do our little custom push function. Got it. Let's move forward. Stack Club. The Stack Club contract, guys, this is kind of a bigger chapter. This is a bigger chapter, to be honest with y'all. So I might wrap it up. We might have a part 2 on the arrays here because, yeah, it looks like there's going to be 2 more questions potentially. I mean, we're about 30 minutes in. So I'll do a part 2 on the arrays, guys. Thank you so much for tuning in. I think that last one was really, really tricky and good to understand. So glad we got there. I will see you on part 2.